Chapter 17, Example 6. SAT scores should have a mean of 500 and a standard deviation of 100. What about the mean of a random sample of 20 students? So we just have a general question about this random sample of 20 students. We want to do that empirical rule, break it down to the 68, 99, 99, 7. So check the conditions. We have a random sample of 20 students, and 20 is less than 10% of all students that take the SAT. It is also reasonable to assume the distribution of scores of 20 randomly selected students would be unimodal and roughly symmetric. I can use a normal model for the sampling distribution of 20 SAT scores. Okay, so mu will be 500. Sigma will be the standard deviation divided by the square root of the sample size. So 100 over the square root of 20, which equals 22.36. We have a normal model, so N 522.36. And so we sketch in our 68, 95, 99, 7 rule. We have the mean SAT score in a sample of 20 students. Put in the 500, take our standard deviation away, go to 3 standard deviations. We know how to do this curve. Make sure you include it. Now we finally want to write it up. According to the normal model, we can expect 68% of samples of 20 students to have mean SAT scores of between 477.64 and 522.36. You might want to round these to 478 and 522 because they're points. 95% of samples to have mean scores between 455.28 and 544.72. And finally, 99.7% of samples to have mean SAT scores between 432.92 and 567.08 points.